If NASA weren't around, what would happen to our universe? Well, I can tell you this. If NASA weren't here, we would know a lot less about the universe. And we would be intellectually impoverished by that fact. Because I enjoy knowing where we are, where we came from, and where we're going. And those questions are answered from space. To know how Earth got here, how the sun got here, what the future of Earth will be, what the future of our sun will be. Will we need to leave Earth and find another planet? All of that comes to us from the discoveries of a space program. Much of those discoveries have come from NASA. So it's not that the universe would be different if NASA never existed. It's that we would be different in a way that I don't even want to think about.
So we wouldn't know a single thing about the universe.
Yeah, we wouldn't know a single thing about the universe. We'd just be rummaging on Earth's surface, thinking that our solutions to all our problems come from looking down rather than from looking up. You know, I'd be embarrassed to show an alien that we kill each other to extract energy sources beneath the sands when the universe is full of limitless amounts of starlight. And, oh, by the way, someone once, reading my tweets, someone asked, when I compose my tweets, am I high? You know, so it was weird. One time I was distracted by a doily, and I was concerned that not enough people paused to reflect on the beauty and majesty of a doily. Right? Just think about what a doily is. And it's just to sit under your cup. And so I got to tweet something about that now. Hang on a sec. Let me do this. Just be a moment. That's right, because I'd already started. So my response will be to those who ask, am I high? Knowing that the sky sits above the entire Earth. That should tell you that the study of the universe is itself a state of natural high. Tweet. Okay. Napoleon, if you visited his library, it's not just sort of books of world history and battles, it's engineering books, it's physics books. This man wanted to know where his cannonballs would land, all right? He was much more than just sort of a lucky general. He was into the physics, the engineering, and the material science of war. And so he immediately summoned up the 5-volume production of Laplace, read it through, cover to cover, called in Laplace, and said, sir, I have the exact quote here. Hang on. Napoleon asked him what role God played in the construction and regulation of the heavens. This is kind of like, that's what Newton would ask, right? Laplace replies, sir, I had no need for that hypothesis. And so what concerns me now is, even if you're as brilliant as Newton, you reach a point where you start basking in the majesty of God, and then your discovery stops. It just stops. You're kind of no good anymore for advancing that frontier, waiting for somebody else to come behind you who doesn't have God on the brain and who says, that's a really cool problem, I want to solve it. They come in and solve it. But look at the time delay. This was a 100-year time delay. And the math that's in perturbation theory is like crumbs for Newton. He could have come up with that. The guy invented calculus just on a dare, practically. When someone asked him, Ike, how come planets orbit in ellipses and not some other shape? And he couldn't answer that. He goes home for 2 months, comes back, out comes integral differential calculus, because he needed that to answer that question. And so this is the kind of mind we were dealing with Newton. He could have gone there, but he didn't. He didn't. His religiosity stopped him. And so we're left with the realization, of course, that intelligent design, while real in the history of science, while real in the presence of sort of philosophical drivers, is nonetheless a philosophy of ignorance. And so, regardless of what our political agenda is, all you have to say is, science is a philosophy of discovery, intelligent design is a philosophy of ignorance. That's all. I don't need to see whether, have you discovered anything lately? If not, get out of the science classroom. But I'm not going to say, don't teach this, because it's real, it happened. So I don't want people to sweep it under the rug, because if you do, you're neglecting something fundamental that's going on in people's minds when they confront things they don't understand. And it happens to the greatest of the minds, as it happens to everyone else, many, if not most other people in the public. Yeah, that's better music here. The face on Mars. Dun, 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 dun. So everybody got excited. Well, sorry, not everybody. Those people who were sure that life on Mars had a simian face, okay? I mean, think about it. Most life on Earth does not have a simian face. Most life on Earth doesn't have a face, all right? So life with which we have DNA in common. All life on Earth has DNA in common. Now you're going to go to another planet and it has a face. The only things on Earth that have faces are like vertebrates have faces. That's a vertebrate face. So you want to say that there are vertebrates on Mars and they're simian in their biology. Well, there's only one thing that looks like a face, no matter the camera angle. And what is that? A face, yes. So we go back at another time, and this is what it is at another time with higher resolution. It looks less like a face. You can kind of see how it might have been. Now, all the Mars fanatics said, oh, the Martians figured out we were looking at them, and they quickly covered up the monument. Then you go back again, and it's like even less like a face. So the Martians have continued to cover this up, apparently. So more on that later. But in fact, I do have the first evidence from the rovers. This photo, in fact, has been kept from the public till I have special connections to NASA, as you heard in the introduction. So this one was the first image taken by the rovers, and it's been suppressed by NASA ever since. Right. So I thought I'd share it with you guys because, like, you know, you're my people tonight here. By the way, if you're looking on Mars for faces, why not look for other things that are familiar? You know, you only see that as a face because we have a face. And familiar things are what you pick out, even if they're not really there. We got the Big Bang. That's been going for a while. Now, not everybody's happy with the Big Bang. You found this billboard. So apparently, God isn't happy with the Big Bang. I would have thought he'd be totally cool with it, but apparently not. I found this bumper sticker in New Mexico. The Big Bang Theory. God spoke, bang, it happens. This one is okay with the Big Bang, but that God did the Big Bang. So people are still trying to wrestle with this. Here's what we know. This is the entire universe in one slide. Quantum fluctuations, birth, an entire explosion, rapid expansion, we call it inflation. That's an idea that came about in the 1970s when there was inflation, severe inflation in our economy. So the word had a lot of currency back then. Now it's like you're inflating a tire, like what are you doing, you know? There is the baby picture of the universe. That's that sort of aqua surface there. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky. There it is, the cosmic microwave background, a record of the earliest moments of the Big Bang. Then it takes a little time to make your first stars. We call it the dark ages. Stars are made, galaxies mature. We come up to the present day, 13.7 billion years later. And that telescope, we can't see the whole name, it's called WMAP, Wilkinson Microwave Anisotropy Probe. They clearly didn't want anyone to pronounce that or remember it. I would just call it the Big Bang machine, that made this measurement. And so it's a pretty coherent picture that we have of the origin of the universe. And here's that map that the space probe shown. And so this is a record of the earliest moments of the universe. And it tells us what the universe was up to. And data agree, we're all pretty happy with this, and we're kind of moving on. If you look at the chemical ingredients of life itself, you remember from biology class, we're mostly water. And good old water is H2O, 2 hydrogens, 1 oxygen. And if you could look at the sort of the element budget of life, hydrogen is number 1, as expressed in the water molecule. The number 2 in the human body is oxygen, turns out. Number 3 in the human body is carbon. 4 is nitrogen. 5, you find on all lists, is other. Okay, now if you go to the universe, that's the O on the periodic table. You didn't know that? That's not for oxygen, it's for other. So you go into the universe, number 1 ingredient in the universe is hydrogen. That was true in life. Number 2 ingredient in the universe is helium. We don't have that one.
It doesn't like anybody.
No, how come? Well, because helium is chemically inert. You can't do anything with it even if you wanted. You can inhale it, okay? And sound like Mickey Mouse, yes. Next in the universe is oxygen. Next, carbon. Next, other. Thank you, in the 3rd row there. So, actually, that was the 2nd row. They must be related to the 2nd row here. We are 1-for-1 matchup with the most abundant ingredients in the universe. Of these, carbon is the most chemically fertile element in the entire periodic table. You can make more kinds of molecules with carbon than all other molecules combined. So, if you were going to experiment through the forces of nature with complex chemistry, and you had to pick an element to base it on, carbon is your man. Or your woman, however that goes. Okay, so what I'm saying is, given what carbon is capable of doing, perhaps we shouldn't be so surprised that there's life, because we are carbon-based life. We're just another one of the things carbon has rolled up its sleeve. Maybe life is inevitable, given the abundance of carbon and oxygen and nitrogen and hydrogen in the universe. Try to invert that view. Otherwise, you're left thinking, hey, we're special. You know I would give you right to say you're special? If life on Earth were made of an isotope of bismuth. That stuff is nowhere in the cosmos, and then we're made of it, we're special. Okay? But if we're the most common ingredients of the matter that we know and love, you don't have an argument.